Now, for this semester, we're going to skip this reaction. And so the last one that we're going to deal with is the iodine test for polysaccharides. This one is faster than any of the others, okay? If we're testing for polysaccharides, well, I mean, the only one that we see here is starch. I mean, the unknown could be a polysaccharide, but water's not a carbohydrate, monosaccharide, and then both of these are disaccharides. This is the only polysaccharide on the list. And this is a very distinct observation. If we look at the experimental part for just a minute, if you look at the sort of the intro paragraph for this test, it talks about the helical shape in, be amylose and amylopectin. Right? You can imagine that like starch and glycogen has this helical structure of a bunch of glucose molecules built up, right? Polysaccharide, many glucose molecules. And what happens is that the iodine gets trapped, forms a complex between itself and the starch molecule. And when it does that, it generates a very unique looking blue-black solution. And it's obvious. You'll see it in the videos. It's a very fast reaction. Now, I'm not going to underline these other ones because they're not terribly important. Glycogen gives a little bit different color than starch. Starch is really the only polysaccharide we have, so that's what you're looking for. One thing to keep in mind is that in part E, we're actually going to use the iodine test and the Benedict's test to determine whether these hydrolysis reactions have occurred down here or not. Okay, so we'll come back to this reaction on part E as well. Okay, so let's watch this short little video, okay?